to is called the marginal product of labor, right? What the marginal product of labor tells us, or the question answers, is how much does output go up by if I add one more unit of labor, holding capital and all other inputs constant, right? So I start at some point, let's say I have 2 units of labor and my 8 units of capital. If I add one more worker, how much does my output go up by? So who here wants to play Starbucks manager for a second? Right there in the middle. Okay, I'm currently employing 11 workers at Starbucks, right? If I'm telling you that the marginal product of labor is -5, would you hire that additional worker? No, right? That means I hire one more worker that I have to pay. Granted, we're not worrying about payment right now, but my overall output would go down. Seems like a bad idea, right? However, if I said you hired one more worker and your marginal product of labor was 20, you'd say maybe, right? Depends on how much that worker would cost me and what that means in terms of overall sales, but it's definitely not a definite no, all right? So the marginal product of labor, I'm going to show you next lecture, is the thing that determines solely, together with price of labor, how many workers you're going to hire and how much output you're going to produce. It is maybe the single most important concept to the firm. For those of you who like calculus, this statement here is equivalent. The marginal product of labor answers the question, what's the change in output due to a 1 unit change in labor, right? It's rise over run, right? How much does output go up or down by if I add one more unit of labor? It's going to be the slope of our total product curve, and I will make that very clear again in a second. The third one, and I mean this is sort of a slacker version of the concept here, it simply says, will an additional worker increase output and by how much, right? How much does output change for a given level of capital if I add one more worker? Now, can we actually calculate this marginal product of labor? Well, I don't think we'd be here if we couldn't. So what I've done here is I've taken the table we saw earlier, this big table, and I've just thrown out the irrelevant columns for this particular concept, and we're going to together figure out what the marginal product of labor is here. This MP in the table should have a little L at the bottom, okay? Got cut off somehow. All right, so we're going to ignore this one, and we can talk about this later. But if I go from 8 units of capital, 0 units of labor, I'm producing 0 units of output, to hiring my first worker, so now I have 8 and 1, my output goes from 0 to 5, so total output went up by 5 units. So the marginal product of labor is 5. If I hire one more worker, I go from 1 to 2 workers, and my output goes from 5 to 18. My change in output is 18 minus 5, it's 13. It's the change in output due to hiring one more worker. Let's do one more boring one, and then let's check our understanding. How about 3 to 4, all right? You go from 36 units of output, you add one more worker, you go to 56, so your marginal product is 20, all right? So I've mapped this here. Whoa, Max, there's one missing. How did that happen? How did this happen? Well, we can fill it in, right? So 4 to 5 is 56 to 75 is 19. 5 to 6 is 75 to 90. What's the marginal product? 15, right? Can you tell I'm teaching a preschooler how to add right now? I'm sorry about the annoying ways of explaining addition and subtraction. It's not you, it's me. All right, what's the marginal product of going from 10 to 11? How many units of output are you adding or losing? 0, right? So the marginal product is 0. Now, you could draw this marginal product if you want, right? For each unit of labor, you have the corresponding marginal product. So let's do that. There is an easier way to do this, and I will teach this to you today, okay? 1 unit of labor marginal product is 5. 2, it goes to 13. 3, 18. 4, 20. 5, 19. 6, 15. 7, 8, 8, 6, 9, 4, 10, 2, 11, 0. Whoa, minus 2, minus 4. We can connect the dots, and this thing looks something like this. Meet your marginal product of labor curve. Okay? This is my marginal product of labor curve. It goes up, and then it goes down. Now, the first thing I want to note already, we're going to examine this thing in great detail, so if you're kind of confused right now, don't worry. It's totally normal. Do you think you'd ever hire more than 11 workers? That's right, yeah? Well, I like that, right? So if you thought about it for a second and you did this graph, you would never hire 11 workers because they have negative marginal product. In the real world, there's of course uncertainty as to the productivity of each individual worker, right? This model here assumes that each worker is identical. You may get a good worker or a bad worker sometimes, so there's uncertainty over labor quality. But the point here is if you knew this graph, right, and there's perfect information here, you would never hire more than 11 workers, right? Because they decrease your total output and ultimately you're going to have to pay for them. So if there is some answer to an exam ever where the optimal answer is we should hire somewhere where the marginal product of labor is negative, your answer is wrong. You should ask for a new sheet of paper and do it again, right? You will never, ever operate somewhere where the marginal product of labor is negative. It's just not rational. Does it happen in the real world? Have you ever hired your cousin because mom called? Yes. And he ate your ice cream, sat around, told jokes, and didn't sell anything. Okay. Second concept, the average product of labor. All right? The average product of labor is simply the ratio of output to the number of workers used to produce that output. So you divide total output by number of workers produced to produce that output, and that's your average product of labor. What that simply is it's an average, right? It's the average number of ice cream scoops per worker. We will see that almost all of the decisions a firm makes depends on the marginal product of labor, not on the average product of labor. In most of economics, most decisions are made based on marginal concepts, not on average concepts. So the answer to the question, will output rise in proportion to the labor hired? That's what average product answers. Turns out, as we'll see, is not a very, very useful concept. Can we draw it? Yes, we can. And the fact that I'm sitting down and drawing these and it's somewhat tedious, it's intentional, right? Because I'm going to show you a quick way to do this, and then you'll be like, wow, Max is like the Michelangelo of economics. Not anywhere near, all right? But what's the average product? It's just divide total output by number of workers. At 0, we ignore that one, right? But if you hire one worker, you're producing 5 units of output. Average product is 5. If you hire another worker, total output goes to 18. Divide by 2 workers, it's 9. At 3, output goes to 36. Divide 36 by the total number of workers. Average product is 12. 56 divided by 4, 14. Thank you. And let's do the other missing one here. 108 divided by 9, 12. Thank you. All right, it's just a division. So again, we can go through the pain in the neck exercise and sit down and draw it. Just for demonstration of how annoying that is, I'm going to do that, all right? Max, I'm paying you so much money, and I don't really want to watch you draw. Tough luck. 3 is 12, 4 is 14, 5 is 15, 6 also 15, 7, 14, 8, 13, 9, 12, 10, 11, 11, 10, 12, 9, 13, 8. Okay, so my average product of labor curve looks something like this. It's just kind of linear out here. It doesn't have to be. So that's my average product of labor curve. So we all agree that if we had this table here, we could draw these three curves. Have we learned anything that we couldn't have learned at home? Right? You could have punched this into Excel and come up with a pretty nice picture of what these look like in one go. I fully agree with you. You could do that. But there's a relationship between the average product and the marginal product that really matter to me and that we're going to study in a great detail. Bad slide, bad slide. Damn it. Ignore this slide. There was supposed to be text there. Okay. Intuition. What will happen to your GPA if you tank midterms 1 and 2 in the final in this class? Well, it depends on what your GPA is, right? That's not funny, Max. Okay. Let's say you're a finalist for the university medal, which every year I look at these undergrads and I'm like, how did you sleep? Really? That's impossible what these kids do. But you have a 4.0 GPA. What if you get a B in my class? I've done this to a university medalist one year. She was not happy. Wasn't intentional. I didn't know she was a university medalist. What happens? It drops, right? So if the grade in your marginal class, meaning the next class you take, is worse than the average grade you've gotten so far, your average grade after having taken this class drops. If the grade in the class you're currently taking is better than your average grade so far, what happens to your average grade? It goes up, right? So the grade taken in a current class is much like the marginal product of labor, versus the GPA is your average product of labor. So if your current grade is better than your current existing average grade, then your average grades will go up after the semester. If the grade in this class is worse than your average grade so far, your average grades will go down. So if you think about GPA and grades, and I'm going to use the green board here for a second. So 0 to 4. If this is your GPA, and this is your grade here, if your grades are better than your GPA is going to go up. If your grades are worse than your GPA is going to go down. Right? Maybe the better line to draw to get this point across is to draw the horizontal line here. Right? If at any point, that's also not so great. It's a good example, but I can't ever really explain it very well. It's said here for 3 years, possibly skip because you're confusing people, Max. But we all get this, right? If you're doing worse than before, any athletes here, baseball players, right? If you have a crappy season, there are certain statistics that tell you the average number of hitting a ball, right, thrown at you. You do worse in the season, that number goes down, right? You do better in the season, that number goes up. So, yeah, stop it. You're confusing people. What does this have to do with anything, Max? Here we go. And I can't do this electronically. This has to be done on the blackboard, so you're getting some return to actually showing up today. I'm going to draw my total product curve. Okay? What goes down here is labor. What goes up here is output. And if you go back and you look at what that total product curve looks like, it was sort of like half of a U, right? And then there was an inverse U on top of it. So go back to the curve I drew 4 or 5 slides ago. The total product curve, if I exaggerate it, it looks a little bit like this, right? And we showed this for 1 unit of labor, 2 units of labor, 3 units of labor, 4, and so on. I'm not drawing this to scale like before. Now, right underneath it, I'm going to draw the marginal product of labor and the average product of labor. Okay. Max, I'm scared. You should be. Okay? But in order to make your life easier, I brought my neon shoelace. So the marginal product of labor answers the question as to, or should we do average product? Let's do average product first. It's easier. The average product of labor tells me at any amount of labor, let's say 1, 2, 3, 4, 5, 6, 7, at any amount of labor, what's the average number of units each worker is producing? Okay? So at 7 units of labor, right here, if we go up, if I know my total product curve, I know that at 7 units of labor, we're producing 98 units of output, taking that straight from that table. So what does that mean, Max? The average product here, average product of labor, is 98 over 7. Yeah, I get that. Let me show you something cool, okay? I'm going to turn average product into a slope of something. So this here is 98 over 7. Well, what's 98? It's the rise from the origin, okay? Start at the origin, go all the way up here to the output produced at 7, that's rise, and 7 is the run from the origin, right? So I go to 7. So 98 over 7 is rise of 98 over run of 7. Rise over run of what? Well, it's just the slope of a line connecting the origin to the total product curve. All right? So what is the slope of the following hot pink line? 98 divided by 7, whatever that is. 14. All right? So why, Max? Why is this a useful way? Am I going to have to get an embarrassing 1980s shoelace? Yes, right? They sell them at Target very inexpensively. But the point here is, if I wanted to figure out what happens to the average product of labor at any point on the total product curve, I just have to look at the slope of my shoelace. So let's do that, right? I'm going to connect the origin to any point on the total product curve. What happens to the slope of my shoelace? Goes up. Here, it sort of peaks. I'm not going to make any career jokes of famous Hollywood actors. Okay? And then, if we keep on going, I'm going to use my finger as an extension here, it starts dropping, right? So let's do this again. So it rises until we get to this point where it's exactly tangent. So let's note this point right here. Okay, shoelace, tangent, right here. So again, slope of shoelace rises, and then it starts falling. That's pretty cool, okay? I've learned something about my average product here. So to the right here, average product of labor is falling. To the left of this point, where if I took a stick, I put it in the origin right here, and then I just sort of leaned it against the total product curve, right? The point where a line from the origin is exactly tangent to that total product curve, right? That's this amount of labor right here. To the left here, average product of labor is increasing. Pretty cool, right? So average product of labor, we showed in our picture earlier, looks something like, it looked fancy, looks something like this, right? So I now know the line where to the left of it it's rising, and to the right of it it's increasing. It tells me something about the average product of labor. Are you ready for my next trick? Yes, you are. Let's go to marginal product of labor. The marginal product of labor tells me what happens to output as I add one more unit of labor, right? The change in output due to one more unit of labor. How much does output go up by if labor increases by 1 unit? Rise, change in output due to a change in labor of 1 unit. It's also a slope. But now the slope is different, okay? The slope I'm talking about, let me pick up a pretty pronounced one, right? The marginal product of labor of going from 6 to 7 units of labor, that means I go from this point here to that point right here, right? Output at 7 is 98. Output at 6 was 90. Definitely not drawn to scale this thing, right? Okay, I'll pick these up later. So I've got my change in labor, 1 unit. I've got my change in output here. How many units? 8, right? So the marginal product of labor is 98 minus 90, that's my change in output, over 7 minus 6, so it's 8 over 1. 98 minus 90, that's the change in Q. 7 minus 6 is the change in L. This is my rise, this is my run, right? So what is the marginal product of labor? It is the slope of the line connecting any 2 points on the total product curve, right? Let's use this amazing thing again here. The slope of this pink line right here, I should do more yoga. But the point here is the slope of this pink line right here, that's my marginal product of labor. Does that only exist at 6 and 7 units? No, I pulled those out of a hat, right? It's true everywhere on this total product curve. It's just the slope of the total product curve. So let's do this, all right? Let me take my thumbs. They're exactly 1 unit apart here. And I'm going to go along the total product curve. What happens? Sort of like Henry Rollins wears his microphone. That seems to be efficient. Okay, here we go. What happens to the slope of this line as I go up the total product curve? Going up, going up, going up, going up. Whoa, whoa. Going down, going down, going negative, right? Let's do this again, because it's so much fun, right? So I'm just tracing out the total product curve. It's going up, 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 and it's going up. What happens right here? Is this like a special point? It's the point where the 2 U's connected, right? Where I went from a regular U to the inverse U. This here's the inflection point. So at this inflection point right here, which is, I don't know if this is right with the numbers I gave you in the class, in the table here, but to the left of this inflection point, marginal product of labor is increasing. To the right of this inflection point, marginal product of labor is decreasing or falling. Is there one more point that's important? Of course. In fact, the news are worse. There are 2 more points that are important. But once we figured out what those are, we can draw this thing so fast. And I'm going to show you how fast you can draw this in a second. Okay, back to our marginal product of labor, okay? Increasing, 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 decreasing, 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 flat goes to negative. So right at the peak here, that's where the marginal product of labor goes negative, right? It's like any election. There's a point where they start going negative. So the point here is, at that amount of labor, the marginal product goes negative. Now, here it goes. I hope you're ready for it. This is amazing. I'm going to erase some stuff here, which you love. I'm going to draw my average product of labor right where it's tangent, right? This is the amount of labor where the average product of labor goes from rising to falling. And now watch the slope of the marginal product of labor as I go past that point. You're excited. Okay, it goes up, it goes up, it goes up, it goes up, it goes down, it goes down. Whoa, 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 what's happening here? Whoa, they're exactly the same, all right? At this point right here, where the average product of labor goes from increasing to falling, the marginal product of labor and the average product of labor are exactly the same. All right? I now have everything I need to draw this stuff. Are you ready for it? No, Max. Okay, start with average product of labor. The way I remember it is the never-ending story is Germany's greatest movie made ever. There's a turtle in there, Morla. That's what average product looks like, okay? Here we go. That's average product. It goes from increasing to decreasing at this amount of labor right here, at the amount of labor where the line from the origin is tangent to the total product curve. So just make some room here. All right? That's my average product. Now, let's draw marginal product. Marginal product of labor is increasing until here, then decreasing everywhere and goes negative here, okay? What else do I know? I know that marginal product of labor and average product of labor are exactly the same at the peak of